All right, guys, so here, number 6. This one's quick. Okay, so here I'm going to do the fishing pole. I'm going to set up my own little, oops, wrong thing. I'm going to set up my own little diagram. So here's the fishing pole. But here I want it at an angle. So let's angle this. Okay, so here's the fishing pole, and there's a force acting on the fishing pole like this. You know, the fish is exerting a force of 100 newtons. Okay? And then if you extend the pole out like that, they show us here that we have the fishing pole makes an angle of 20 degrees with the horizontal, and then the fish is pulling at 37 degrees from the horizontal. So together, this angle here is 57. Okay? So together, that angle there is 57. The axis, in fact, I think they tell us in the problem, yeah. What is the torque exerted by the fish about an axis perpendicular to the page and passing through the hand of the person? So axis being right here, perpendicular to the page. When they say that the axis is perpendicular to the page, that means that the fishing pole can rotate in the plane of the page, right? It could either rotate up the page or down the page. All right, so our axis is there. The length of the fishing pole is 2 meters. Okay, now look, here's the thing. We're trying to find the torque caused by this force. The torque equation is force times distance. What has to be true when you're using this torque equation? The force and the distance must be perpendicular. Is this 2 meter perpendicular to the force? Because that makes a 57 degrees. I mean, if that were 90 degrees, we'd be set. If that were 90, we'd be all set to go. So you could either make, there's 2 ways to do it. You could either make the force perpendicular to the distance, or you could make the distance perpendicular to the force. So let's make the force perpendicular to the distance. Here's how you'd make the force perpendicular to the distance. So I'll get my red pen out. Something like this. Ready? Watch. Boom. See that red guy right there? Is that guy perpendicular to the 2 meters? Yeah. So we're going to go boom and boom. Like that. So that makes a 90 right here. So what would this angle in here be? That's 57. So what must this be? 33. So what's this guy going to be right here? This vector right there is going to be what? Cosine 33 times 100 newtons. You guys see that? I just made a triangle. I just did some vectors. Okay, so to find the torque, we're going to go, all right, so the force we're going to use this force, because that's perpendicular to the 2 meter. So you're going to go cosine 33 times 100, then multiplied by the 2 meter, okay? And then this comes out as 167.7 Newton meter. Newton meter, it's technically equivalent to a joule, but when you're talking about torque, the convention is you leave it as Newton meter. Okay? All right, now look. There's another way we could have done this. We could have made the distance perpendicular to the force. So let me just show you that way. So to do it that way, what you do is you extend the force, right? Extend the force like that. Then you can draw a perpendicular distance to it, right? So when you say, so torque is force times distance, what's the definition of this distance? The definition of that distance is what? It's measured from the axis, and it's got to be what? Perpendicular to the force. So look, you can go like this. Bam! This distance right here is perpendicular to the force. And look, we're going to do the exact same thing. What's this angle in here? That angle in here is going to be what? Well, what's this angle in here? That's 57. So what does this have to be? 33. So now what's this distance right here going to be? That distance is going to be what? Cosine 33 times 2 meter. All right, so let's do it again. Torque equals force times distance. So now we're just going to go, okay, force is 100. Okay, and then we're going to use this distance. Cosine 33, 2 meters. Notice that this and this are the same. So you could either make the force perpendicular to the distance, or you can make the distance perpendicular to the force. All right, Spaldo out.